All right, welcome to part 2 of the unit circle. We're going to start with defining what a reference angle is. It's an angle between 0 and 360, and any angle between 0 and 360 has a reference angle. The reference angle is going to be the acute angle created by the terminal ray and the x-axis. A reference angle can be created by dropping or raising a perpendicular segment between the x-axis and the terminal point of the terminal ray on the circumference of the circle. So let's take a 130-degree angle to get a better idea of what this is talking about. If I start at the positive x-axis, which is 0 degrees or 0 pi, and I go around the unit circle, once I've gone up to the top, I'm at 90 degrees, which is of course pi over 2, and 180, and 270, and back to 360. Always starting at the positive x-axis being 0 degrees. So if I'm going around to 130, that's definitely past 90 and before 180. So we'll just say for argument's sake that it's about right here. This would be the terminal ray of that angle. And this angle from here, from 0 around, would be our obtuse 130-degree angle. The reference angle and the reference triangle are created by dropping a perpendicular or raising, if you're in quadrants 3 or 4, to the x-axis. So the reference angle would be 50 degrees to get all the way to 180. So there we go. So if we want to know the sine and the cosine and the tangent of 130 degrees, that would be associated with the sine, cosine, and tangent of 50 degrees because they are supplements. So if I take my graphing calculator here and I find the sine of 130, I get a positive 7,660. You can see that here. If I take the sine of 50, I also get 0.7660. And that's because both 50 degrees and 130 degrees have a positive sign. 50 degrees would be up here. The sign is the y-coordinate on the unit circle, so that would be positive. And the sign here would be positive. So that is 0.7660. And again, we're talking about on a unit circle. If I wanted the cosine of 130, so I do the cosine of 130. You can see it's negative 0.6427 or 28 if we round it, and compare that to the cosine of 50. The only difference is that one is positive and one is negative. The reason cosine of 130 is negative is because we are in quadrant 2 and cosine is the x and we're going left. If we're doing cosine of positive 50, we're going right, so that's why the cosine would be positive. So for that, it's negative 0.6428. So negative 0.6428, positive 0.7660, and then of course the tangent we can already predict will be negative because we're doing a positive divided by a negative. We're in quadrant 2. Tangent of 130 is the same as the tangent of 50, only one is negative and one is positive. So for 130, it's negative 1.1918. So what we're going to do is practice this going around the unit circle with some familiar 45, 30, and 60-degree multiples between 0 and 360. And we'll look at the sines, cosines, and tangents, and you'll see they're all the same as the reference angle, except for changes in sign as you go around to the different quadrants. So we're going to start with our reference angle of 45. We already did 45 degrees in the first quadrant in the previous video, so I'm just going to throw that on here with a hypotenuse of 1. And the x-coordinate, or the cosine, is square root of 2 over 2. And the sine is square root of 2 over 2. So And for this one, we know the tangent will be 1 because we're doing y divided by x. So that's at 45 degrees. So where are we going to end up over in quadrant 2 that will also have a reference angle of 45 degrees and create that reference right isosceles triangle? Well, we could either take 90 and add 45 or 180 and subtract 45, and you can see that that would be 135 degrees. Now, once we've got this basic unit circle in quadrant 1, all the x and y coordinates are going to stay the same, except for this one's going to be negative and this one's going to be positive. It's always great to ask questions on the test about which quadrants will have negative and positive signs or negative and positive tangents, because that shows that you really understand where you're moving around the unit circle. So this is going to be 135 degrees. Now, if we want to look at that in radians, given that pi is 180, we're looking at 3 pi over 4. Because if you think about it, this is 1/4 the way to pi, 2/4 or pi over 2, 90 degrees, pi over 2. This is 3/4 the way to pi, and this is pi when you have a circumference of a semicircle with a radius of 1. So for 135 degrees, which one's going to be negative? You can see that's going to be cosine, the x-coordinate, which is adjacent over hypotenuse. So for cosine, we have negative square root of 2 over 2. For sine, we still have a positive y, square root of 2 over 2. And for tangent, it's going to be 1, but it's going to be negative because the x-coordinate is positive and the y-coordinate is negative. All right, let's do one more together, or this might be a good time for you to pause the video and try to do the last two on your own. The reference degree of 45 in quadrant 3 and the reference degree of 45 in quadrant 4. If you think you're ready to try those on your own, pause the video now and then come back and check them in a minute. All right, so if we're looking at these, 45 degrees past 180 or pi, we're talking at 225 degrees. 225 degrees. So we can see that we still have the cosine that is negative. The sine this time is going to be negative, which means the tangent, when you divide sine by cosine, or y divided by x, is going to be positive. And then in quadrant 4, if you're 45 degrees away from 360, or 360 minus 45 degrees, we're going to be talking about 315 degrees. And as you can see, we will have a positive cosine, a negative sine. And then tangent is a positive and a negative, the quotient of sine over cosine, which will be negative. Positive cosine, square root of 2 over 2, negative sine. And those are your values between 0 and 2 pi. So the question is, what would be the radian measure for these? Well, if 180 is pi, this is going to be 1.5 pi, or 3 pi over 2, or 6 pi over 4. So if this is 4 pi over 4, because it's 1, and 6 pi over 4, because that's 3 halves, this would be 5 pi over 4, which I just wrote down here. And then 315 is between 6 pi over 4 and 8 pi over 4, which is 2 pi. So it will be 7 pi over 4. Just keeping up practicing with those radian measures for pre-calculus later on. right, so next we're going to do our 30, 60, 90 triangle. Speed it up a little bit since we are getting more familiar with this process. So going back to the 30-degree reference triangle that we did in the previous video. Radius of 1, we're on a unit circle. So we're throwing our 30, 60, 90 rules on this picture. Short leg is half of the hypotenuse. Long leg is square root of 3 times the short leg. That gives us square root of 3 over 2. And so for 30 degrees, which is pi over 6 radians, 180 divided by 6, we have a sine, which is positive 1/2, a cosine, which is positive square root of 3 over 2, and our tangent is opposite over adjacent, which is going to be 1 over square root of 3, or square root of 3 over 3 rationalized. And we could also get that decimal approximation, which is about 0.5774. But I'm just going to leave them in simplest radical form for this. Okay, so if we're going to go with a 30-degree reference angle in quadrant 2, okay, we're going to be talking about 150 degrees away from 180. And this time we're going to have negative square root of 3 over 2 and positive 1/2. Which means our sine is going to be positive 1/2. Our cosine is going to be negative square root of 3 over 2. And our tangent is going to be the same as the previous tangent because we still have the same opposite and adjacent, opposite, adjacent. It's just that now we're going to have a negative tangent. So this is 150 degrees. And then we're going to have 30 degrees beyond the 180. So if we have 180 or pi, we are going to have 30-degree reference angle. We're talking about 210 degrees. So we're going to have a negative cosine, and this time a negative sine. When I'm filling in my trigonometric values. And then our tangent this time is going to be, you might have predicted, it's going to be positive because we're doing a negative divided by a negative. So it's still square root of 3 over 3. And this time it's positive. And then for over here, 30-degree reference angle in quadrant 4. We're at 360 or 2 pi, take away 30, that leaves us at 330 degrees. So we have a positive cosine of square root of 3 over 2, a negative 1/2 for the sine, so a positive cosine, a negative sine, which gives us a quotient as a negative tangent. Let's go back and look at these radian values. I'm going to encourage you to try the next one with the reference angles of 60 all yourself. So if we're looking at 30 degrees, which is pi over 6, it helps to look at all these with a denominator of 6. So pi over 2 would end up being, if this is 1 pi over 6, okay, every degree of 30 is a pi over 6. So it would be 2 pi over 6, 3 pi over 6. Okay, and 180, which is pi, is going to be 6 pi over 6. So if we take away a pi over 6, that means that 150 is 5 pi over 6. 210 is going to be 6 pi over 6 plus another pi over 6, another 30 degrees. That's going to make it 7 pi over 6. And then 360, which is 2 pi, which is 12 pi over 6. If we take away a 1 pi over 6, that means it's 11 pi over 6. So these are all our trigonometric values in simplest radical form for reference angles of 30. I would encourage you to pause the video and should try to do all the ones for 60 on your own, starting with quadrant 1 of just 60 degrees, which is pi over 3. So if you want to pause it, work on it, and then come back. All right, let's work out these reference angles of 60 degrees as we go around from 0 all the way around the unit circle back to 2 pi. So in quadrant 1, which we did the other day, pi over 3, or 60 degrees of a reference angle on a unit circle with a radius of 1, short legs 1/2, long legs square root of 3 over 2. So that will help us to get our sine, cosine, and tangent values. Square root of 3 over 2, sine is the y, cosine is the x, tangent is the y divided by the x. Reciprocal and multiply, that ends up giving us square root of 3. So this tangent has a value of greater than 1, which makes sense because the long leg is shorter than the, or longer than the short leg. So the tangent is going to be greater than 1. Let's go into quadrant 2 with this other 60 degree reference angle. So that's going to put us at 180 take away 60, which is going to leave us at 120 degrees. We'll come back and work out the radians in a minute. All right, we're going to have negative 1/2 and positive square root of 3 over 2 for our cosine and sine respectively. And then the tangent is going to be negative because we're doing a positive sine divided by a negative cosine. So negative square root of 3. 60 degrees into quadrant 3. Negative cosine. Negative sine. And that's going to be 60 degrees beyond 180. That's going to give us 240 degrees. So our cosine is negative 1/2, the y coordinate, and our tangent is a negative divided by a negative, which is a positive square root of 3. And last but not least, over in quadrant 4, 60 degree reference angle to the x-axis. We have a negative sine and a positive cosine and a negative tangent when you divide negative by positive. So that's going to be at 300 degrees, 60 away from the x-axis, 60 away from 360. Sine is negative, cosine is positive, and tangent is negative, just as we said a moment ago. Looking at the pi values, I'm going to keep everything denominators of 3 because 60 degrees is 180 over 3 or pi over 3. So this is 1 pi over 3. Okay. This is 2 pi over 3, 2/3 of 180. So I'm going to write over here 2 pi over 3. Pi is 3 pi over 3. 240, 3 pi over 3 plus another pi over 3 is going to make it 4 pi over 3. And last but not least, 300 degrees, which is 2 pi, which is 6 pi over 3. Take away a pi over 3, makes it 5 pi over 3. So these are all our trigonometric values with a reference angle of 60. So now we're going to look at some odd ones. A reference angle of 90. This will be our final one. So we're going to go strictly with the definition that sine is y and cosine is x and tangent is y divided by x. So we get focused here. So if we are at 0 degrees, which is the same as 360, which is the same as 2 pi. We can also do sine, cosine, and tangent at 90, which is pi over 2, halfway to pi. At 180, which is pi. At 270, which is 3 pi over 2. And remembering sine is y, cosine is x, and tangent is y divided by x. If we start at 90, which is the coordinate 0, 1, so the cosine is 0 and the sine is 1, x and y. And tangent is the y divided by the x. So if we do 1 divided by 0, the tangent is undefined. There is no tangent of 90 degrees. Sure enough, you can confirm that this isn't craziness on your calculator. Tangent 90, error domain. There is no tangent for 90 degrees. Let's do 180 next, which is pi. So we are at the coordinate -1, 0. Can't really make a triangle with that. So the cosine is x, which is -1. The sine is y, which is 0. And the tangent is y divided by x. 0 divided by -1 is 0. Thirdly, 270, 0, -1. And 360, which is also 0 degrees, is going to be at 1, 0. I encourage you to stop the video here and try to finish filling in the sine, cosine, and tangents for 270 degrees and 360 or 0 degrees. If you want to pause it now and then come back. All right, so for 270 degrees, the sine is the y, which is -1. The cosine is the x, which is 0. And the tangent is the y divided by the x, again, undefined. For 0 degrees, 360 degrees, or 2 pi, cosine, sine, cosine, sine, tangent is sine divided by cosine. Oh. Got that backwards there. Sorry about that. Let's fix that. Let's just keep going here. So I got my sine and cosine, my tangent, my x and y backwards. So the sine is the y coordinate, which is 0, and the cosine is the x coordinate, which is 1. I got them backwards. Okay, there we go. And 0 divided by 1 is 0. That's much better. All right, so these are all the trigonometric values with a reference of 90 degrees. Good luck finding your angles.